Let's go ahead and get started. So hello everybody, my name's Daniel Grimmer. I'm a DPhil student doing philosophy of physics here in Oxford, and I'm going to be giving a 4-lecture series on the metaphysics of the laws of nature. So let's just get into it. So I hope you all will find this to be a philosophically interesting subject matter in its own right. I'll try and convince you that it is. But questions about the laws of nature, what their metaphysical status is, show up all throughout contemporary debates in analytic philosophy, and that's mostly what we'll be talking about in these lectures. For instance, they show up in counterfactuals. When we want to know what would happen if something else had been different, we oftentimes keep the laws of nature fixed. And so they have a role in grounding counterfactuals. We'll talk a lot today about causation. Laws are very involved here. We'll talk about different kinds of explanations. There's sort of scientific explanation, metaphysical explanation. We'll get to a key difference about that later, about the roles that laws of nature might play in each of those kinds of explanations. The laws of nature, as we know them, are often deterministic, or certain interpretations of quantum mechanics, indeterministic. And that has lots of philosophical consequences for free will and moral responsibility and things like that. Induction. How do we know the laws? We look at a bit of data in our laboratory, we do a few experiments, and then we claim to know generalities about the entire universe. How is that possible? Or if we want to explain induction, we seem to need some sort of like uniformity principle. Like we know the sun will rise tomorrow because the laws of gravity say it will. And this is how we get past inductive worries. So laws of nature, relevant there again. And natural kinds. If you want to know what sort of the kinds of things are, what nature is in its own terms, let's say, you might want to look to the laws of nature to see they talk about electrons and protons and fields or particles or whatever they talk about. That's a good way to look for natural kinds, possibly, to see what the law talks about. Okay, so we're just going to talk about laws of nature themselves rather than sort of all those connections. They'll come up, but focus is on the laws of nature. And there's this great book by Walter Ott, which I'll show you references for at the end. But we should start with some conception of laws of nature just to know what we're talking about. So we're going to go with a very metaphysically thin notion to start with, and then we can put more metaphysical weight onto it as we sort of go along. But functionally, what are laws? What do they do for us? The laws of nature are sort of general propositions. They're not about this chair being here or that thing being red. They're general things that should apply widely. And they should play a sort of axiom-like role relative to a certain scientific discourse. So they're not argued for, they're sort of stated as premises. They should be the bedrock of your thinking. And you should go to them to sort of make your deductions, conclusions, and predictions. And what the laws should do, they should help us explain things, as I mentioned, but at least they should help us explain things by sort of unifying different stuff into a single account. The law of gravity applies to apples just as well as planets. And we'll see that in a moment. So here's our first example, is Newton's law of gravity, probably the most famous law that there is. And it's invoked as a sort of axiom within Newtonian mechanics. As we'll see later, Newton sort of refuses to explain what's going on with his law of gravitation. But it's taken as just a basic principle for doing calculations, for making predictions. It's right there at the bedrock of the theory. But it's not treated in that way in Einstein's theory. It's not even true in Einstein's theory, but it's like approximately true. But in there, the approximate version of Newton's law is not treated as a bedrock principle. It's like a theorem, like a derived result within that theory. So the same law might play an axiom-like role in one theory, and not in another. So right now we're sort of working in a theory-specific way, but of course the world doesn't care what theory we're using. There might be laws of nature in a theory-independent way that we'll talk about later. Newton's law, it unifies the motions of apples and planets together. This is this sort of unification explanation thing I'm talking about, but it doesn't, Newton refuses to explain how his action at a distance works. He doesn't want to feign hypotheses about this. He just sort of says that's a future topic and somebody else can handle it, but we'll get to exactly what he says later. But that's sort of what laws are and what they do for us functionally. But we want to know what they are in themselves, like what are they metaphysically speaking? And we'll get to that. But let's start with some history first. So throughout history, scientists have used laws of nature as sort of theoretical rules or groundings for their theories, which are helpful in designing experiments, making predictions, and people just generally talk about laws that govern the world. Let's look at those two words, laws, govern. Those are political words, right? So can we take that like political language seriously? We'll see people trying to do that later in the talk. We probably shouldn't. That sort of requires that material objects be sentient and they can like receive orders and obey them, and that seems strange, right? So it's sort of like a metaphor. You should probably read this as metaphorical language. That's a position we'd have to argue for. I just want to say that this legalistic metaphor of laws of nature, it didn't exist at all times and across all cultures. It sort of arose at a certain point in history by natural philosophers to do a certain role in their philosophical and scientific discourse. Like, why did they come up with laws of nature as a concept? And it's been useful and it's stuck around, so we still have it and still talk about it. But we're going to start the lectures with a bit of historical genealogy about this topic. So most of the lectures will be spent on contemporary debates about metaphysics of laws of nature, but we're going to do some history first. We need a genealogy sort of the laws of nature concept. And I'll spend a lot of today talking about Descartes, because there was a big moment in the early modern period where Descartes sort of put down his conception of laws of nature, which was very novel at the time. And we'll see how that all sort of worked. And so the historical questions we're going to start with sort of today are, before that early modern period with Descartes, what kinds of proto-laws, we might call them, were around in philosophical discourse, like Aristotle and the medieval tradition? We have sort of Aristotelian laws. What are those like? And what had to change? What sort of barriers had to be overcome to get from the Aristotelian laws to the sort of early modern laws, right? With the laws of inertia and gravity. Those are a very different kind of laws, and they really come onto the scene at a certain point. So what's that historical transition like? And then once we have laws of nature in an early modern sense on the table, how are they used in various different metaphysical pictures of the day? Descartes, Newton, and Hume we'll talk about today. And then after we've done some history, we'll do metaphysics, okay? So again, there's this book by Ott, which I really like. He sort of divides up the laws discourse on two axes, which I think is helpful. I'm just going to get some metaphysical positions on the table, and then we'll get back to the history and see examples of them. But okay, the first is a top-down versus bottom-up view of laws. So do the laws really govern in like a top-down way, like God or a king imposes them and they're sort of enforced downwards on the world? So in a top-down view of laws, the laws of nature do this. They play a sort of crucial role in determining what happens in the world. And lots of physicists talk in this way. They'll talk about how they make predictions. They say the course of events are fixed by the laws of nature plus the world's initial conditions. You like tell me the states, the places and velocities of all the particles now, and you tell me Newton's laws, and from that everything else is determined, right? You have the stuff and its places and properties, and then you have the laws as a separate thing, and together they make it all happen. So what that means is you might know every possible fact about the properties and positions of all the particles in the world, past and present, up to this moment. But if you don't know an additional thing called the laws of nature, then you'll be at a loss of what happens next, right? So the laws are coming in a significant way to make things happen. And in sort of technical speak, the claim here is that the laws of nature don't supervene on the world's non-gnomic facts. That there could be differences in the laws without differences in the stuff. The same stuff, just knowing that doesn't fix it. I need to know the laws. And those could be different given the stuff. That's a top-down view. Maybe that's intuitive to you, maybe not. That's on the bottom-up view, which we'll see examples of later today. If we've got two worlds with the exact same distributions of properties and stuff, then they can't help but have the same laws of nature. On this sort of view, it's the world that fixes the laws of nature, not the other way around. Okay? How might that work? One way to make that work is that the real sort of metaphysical causal work in the world isn't laws coming down and being enforced on the world, it's material bodies themselves having causal powers, pushing each other around, making stuff happen. There's no governance from the outside, it's just bodies doing what they do and causing each other to do what they do. Right? So on this sort of view, this bottom-up view, if we had two initial conditions with the same stuff, with the same causal powers, the same result would come out of this. No outside governance required. It's just the stuff has its causal powers and does what it does. And laws are maybe a description or a summary of that, but like the real actions happening in the bodies themselves.
Can I ask a question?
Yeah.
What difference do you see between causal powers and the laws?
We'll get to that a bit later on in the talk, but it's really whether there are causal powers in the bodies versus, say, in God's thoughts. The top-down views are very theological, as I'll argue later, but we'll see more about that later. Okay, a second distinction is the sort of enforced versus unenforced regularities. So is there something in the world that enforces the law-like regularities? We see all these law-like patterns out in the world. What makes them so? Are they necessary in a strong sense? Enforced views will say yes, either the governing laws make the patterns or the causal powers in the world make the patterns. So that's their answer there. But there's a third kind of view that says no, the world is just sort of a mosaic of non-causal properties spread out over space and time. This is called Humeanism. That's called the Humean mosaic. Imagine the world as a big painting with all the properties spread out over space and time. There's red paint here, shiny paint here, dull. All the properties you could imagine just sort of spread out over space and time. But in that painting metaphor, no bit of paint causes another bit of paint to do anything. If I had changed this bit of paint from red to green, it doesn't affect any of the other bits of the painting. They're sort of just all there, adjacent to each other, not causing or forcing each other in any way. And so it's just a distribution of properties and stuff. And the mosaic does have law-like regularities in it on this sort of view, but nothing really makes them necessary. There's no force either from outside or from inside. It's just sort of all there. And the laws of nature are just efficient summaries of these regularities. So it's a very metaphysically light view. It just sort of, we have patterns in the world, there are regularities, they're best described in some way. Those are the laws of nature. And you might pick those out in like an objective and mind-independent way. So they're real, the laws of nature are objective, but they're not doing any sort of work. So here's the overview of the lecture series. We've got first lecture on the history of the laws of nature concept. And we'll go through that and we'll see examples of these three kinds of views, the governing views, the causal powers views, and the regularity views. We'll see historical examples of all of those today. And then we'll sort of, in lectures 2 and 3 and 4, go into those positions individually and analyze them in a contemporary debate, in contemporary setting. So hopefully that's a clear overview of what the course is going to be about. Any questions at this point? Okay, no, we'll jump into it then. So conceptual origins, where do sort of the ideas of laws of nature come from before they were called that? We had this thin notion of laws that I put up earlier. They play a sort of axiom-like role in a sort of scientific or philosophical discourse. So let's start looking for axiom-like roles being played in ancient or scholastic philosophy. So we can look anachronistically to find examples of these proto-laws in a lot of different ancient thinkers. In geometry, we had Euclid, wrote down his 5 axioms. This is sort of where axioms come from. The idea of axioms anyway, and these 5 geometric principles from which all other geometric truths were sort of to follow. You didn't question those, they were supposed to be obvious, and then you sort of have them as the bedrock of your theory. In astronomy, Ptolemy had a great astronomical model for predicting where the planets would be moving, because they wander back and forward across the sky. That's what planet means. But he had some sort of rules for making calculations, and he had sort of proto-laws in his system to say how all that happened. And our third example from ancient philosophy is Aristotle. We'll talk a lot about Aristotle. His sort of explanatory method, what counted as a good explanation for Aristotle, roughly speaking, was that you first reflect on the essential natures of whatever you're thinking about. You think about smoke and what it's like and what it does, and you find out that it's in its nature to rise. Smoke tends to move up. And apples fall, and fire burns, and knives cut, and you sort of find out what it is that the things do, and you think of them as having those sort of causal powers to affect things in the world. And then you use these claims as the basis of a syllogistic demonstration. So you then do like deductive logic, basically, Aristotelian logic, with those as your premises. It's in fire's nature to burn, therefore I stick my hand in and I get burned. Or it's in man's nature to be mortal. Socrates is a man, Socrates is mortal. You use those as the bedrock of your sort of deduction. So that's why they sort of count as laws in this sense. Now, but we want to get to laws of nature in the early modern period, where they're called that and what Descartes put forward. So what has to change between these proto-laws and the early modern laws? So Descartes had his laws of inertia, Newton's laws of gravity. What sets those apart historically is sort of that they were simple mathematical rules which universally applied to all kinds of bodies. Every body has inertia, every body has gravity. It's not just describing the nature of fire in itself, it's like describing the nature of all bodies. And they're mathematical, they're quantitative. We can make quantitative predictions from them. So Euclid and Ptolemy get us sort of halfway to that. They've got their simple mathematical quantitative laws that let us predict things about the world in like numerical terms. The ratio of these lines should be greater than the ratio of those lines, and the durations of eclipses and things. They like made numerical predictions. So that's great, but they've got a sort of limited scope. They don't apply to all bodies, just to mathematical or geometric figures or the planets. Like, why does smoke rise? We want our laws of nature to do like a lot of explaining for us across all disciplines. But these laws don't have that, these proto-laws. Okay, Aristotle, on the other hand, gives us sort of the other half of what we want. In principle, Aristotelian powers can sort of be used to explain behavior in any kind of body, smoke and fire and apples and knives and stuff, at least individually. And this is where we get into some trouble with Aristotle. His view, by the way, is a causal powers view, sort of the canonical one. The world's events proceed as they do, not because there's some laws of nature outside governing things. No will of God is forcing things to happen. It's the essential natures of the bodies involved that sort of makes it all go. So that's a causal powers view. But Aristotle only ever characterizes these powers qualitatively and only sort of in isolation. And this is a characteristic of his philosophy. We know that apples fall by sort of reflecting on what they do, and they fall at some rate or other. Don't have numbers for that. And they do that only when they're left to their own devices. Okay? If I take an apple, I could try and disprove his theory by lifting it in the air. That apple moved up. Explain that. Or you throw it in the air, right? Moving up, I'm not even touching it and it's moving up. Explain that. And he says, well, that's just you interfering with the natural order of things. Of course, strange things happen when you like start shaking stuff. Like, of course, strange things will happen then. When you leave things alone, they behave in this way. That's what Aristotle is trying to say. And if you interfere, all bets are off. We don't know. Don't know what would happen then. But he doesn't have much of a story to tell us anyway. So for Aristotle, there's lots of different kinds of bodies, and each one has their own sort of special powers, and the powers can interfere with each other. The table stops the apple, after all, and so the world's orderliness in general has to arise from a very complex interaction of all these qualitatively described powers sort of interacting with each other. And I want to point out that that's not a problem for the laws of nature concept in itself. There's a problem for mathematizing these things and for making them universal, but it's not a problem for the laws of nature concept. We don't have to think of laws of nature in the way that Descartes did, or I'll tell you more about him later, as if they're imposed onto nature by a god or a king, some sort of outside controlling force. There's another way to think of laws, which is more like common law. If any of you know about that. Might have a web of laws that sort of dictate how the individual natures of the bodies, and they have the causal power ultimately, and this is the view of like Francis Bacon and Spinoza, how those interact with each other. So you might say that in this sort of scenario, then this person with those powers is supposed to do this thing. You sort of legislate what the people granted powers do with their powers, and it's sort of connecting powers in the world. That's maybe what the laws do on this sort of Aristotelian convention. So that's a fine way to talk about laws of nature metaphorically. But in this sort of Aristotelian framework, it would be hard to do mathematics with his qualitative powers interacting in messy, complicated ways that we can't really get to. So we do have to sort of critique the Aristotelian framework, if not causal powers in particular, to get to a laws of nature concept from the early modern period. So let's now start seeing early modern complaints against Aristotle and his sort of causal powers. So to move towards these simple mathematical laws with universal scope that we sort of see in Descartes and Newton, we need to have some critiques of Aristotle. And here's a very funny excerpt from this play, Molière's The Imaginary Invalid. This was a very common type of complaint against philosophers at the time, to those who were educated. The scene of this small bit of dialogue is there's a medical student, and he's taking a qualifying exam to become a doctor. And he says, this is the student, I am asked by the learned doctors for the cause and reason that opium makes one sleepy. To this I reply that there is a dormitive virtue in it, which is like a causal power, an Aristotelian power, whose nature it is to make the senses drowsy. And the doctors reply, very, very well answered. That's great. The worthy candidate deserves to join our learned body. This is all satirical. This is an incredibly satirical play. Has he really explained anything? Opium makes us sleepy because it has within it the power to make us sleepy. That's no explanation. It's nothing. So there was a turn where people sort of got sick of this kind of explanation. And here's Descartes making such a complaint. The Aristotelian powers were said to come from the substantial forms of the bodies. That's just a bit of terminology we need to know to understand his complaint here. He says, but no natural action at all can be explained by these substantial forms, since the defenders admit that they are occult and mysterious, and that they don't understand them themselves. If I say that some action proceeds from a substantial form, it is as if to say that it proceeds from something they do not understand, which explains nothing. So these forms are not to be introduced in explaining the causes of natural actions. That's a pretty sharp critique of the sort of Aristotelian framework of explanation. And Descartes wants to get rid of all sort of Aristotelian powers and just focus on motion and size, shape, and arrangements of parts. Here's another quote from Descartes. If you find it strange that in explaining these elements, and explaining the sort of physics he's talking about, I don't use qualities called heat, cold, moistness, dryness, as the philosophers do, I shall say that these qualities appear to me to be themselves in need of explanation. Indeed, unless I'm mistaken, not only these four qualities, but all others as well, including the forms of inanimate bodies, can be explained without the need to suppose anything in the matter other than motion, size, shape, and arrangements of parts. So he really wants to get rid of all those mysterious, occult Aristotelian qualities and focus on stuff, like bits of matter and how they move around. There's an extended sort of discussion of how we would apply that in particular to fire. When fire burns wood or other similar materials, we see that with our eyes that the small parts of the wood, it moves the small parts of the wood, separating them from one another, thereby transforming the finer parts into fire and air and smoke, and leaving the larger parts as ashes. Someone else may, if he wishes, imagine the form of fire and the quality of heat and the action of burning to be different things in the wood. For my own part, I'm afraid to stray if I suppose there to be in the wood anything more than what I see must necessarily be there. So I'm satisfied to confine myself to conceiving of the parts of its motion. You may posit fire and heat in the wood and make it burn as much as you please, but if you do not suppose, in addition, that some of its parts move around and move about and are detach themselves from their neighbors, I can't imagine it undergoing any change or alteration. So all the work is being done by the parts moving. If the causal powers are happening, they're somewhere in the back causing stuff to move around. But let's focus on the bits that are moving around. Let's focus on motions of bodies. Get rid of all that powers, and let's simplify the framework and work from there. So we have this sort of mechanical metaphysics which is coming around at this time, and all change is reduced to changes in the motions and arrangements of bodies. And hence, if matter has any causal powers left, it's only the power to move other things and to be moved. It's just bits of matter moving around, pushing on each other. There's only one power, if there are any powers at all. Now, with this like grand simplification of the Aristotelian framework, we don't have all these messy, complicated fire, burns, knife cuts things. Just motion of bodies. Let's just focus on that. And then we have a shot at getting simple mathematical laws for this one power that applies to all things. Right? That's how we make the transition to early modern laws. And these will be the laws of motion that Descartes and Newton will describe for us. But Descartes' critique goes further than this. He doesn't want there to just be one power, the power of motion. He wants there to be no powers. So he denies the existence of any sort of causal powers within or between bodies in what he calls the little souls argument. So Descartes, for context, thought of gravity as a kind of motion which is produced by a real contact between two surfaces. He wants all forces to be mediated by contact. So he wouldn't like this gravitational action at a distance stuff. By contrast, he takes the scholastics to believe that heaviness is a quality, quote, of which all we know is that it has the power to move a body towards the center of the earth. But Descartes thinks that this means we have to treat heavy bodies as if they have some knowledge of the center of the earth. How does it know where to go? How do particles know how to behave? But this surely could not happen without knowledge. And there could be no knowledge except in a mind. Okay? So how do things know what to do? They can't know what to do, they're just stuff. It's not mind. So Descartes, in other bits of philosophy, has this very famous mind-body dualism. He draws a very strong distinction between mind and body. So he wants to say, if you know things, you're a mind. If you don't, you're a body. And that's not exactly the line he draws, but you can't know things without being a mind. So how can Descartes has a puzzle. How can sort of physical bodies be directed at each other or have knowledge of what to do or knowledge of each other? How can the qualities that one body has come to bear on another? How can they reach out and be sort of directed or oriented intentionally towards something? That seems like stuff only minds can do. So Descartes either has to give matter these little souls that he sort of is complaining about, or he has to think there's no such thing as causal powers within material bodies. And he's sort of drawn to this dilemma, and he chooses to deny that matter has little souls, and he chooses to think that they have no causal powers, therefore. So matter doesn't even have the power to move or to know where to move or to cause other things to move. It doesn't have any, it's completely passive, completely inert. But making this denial, Descartes seems to also deny that material bodies have the capability of obeying laws in the first place. You can't obey a law if you have no powers. You have to have some power to carry out the law. So as Robert Boyle puts it, to speak properly, a law being but a notional rule of acting in accordance with the declared will of a superior, it's plain that nothing but an intellectual being can be properly capable of receiving and acting by law. So he's agreeing that you would need a mind for these things, but you need a mind to do things in the world, be oriented towards other bodies to affect them, but also to follow laws. So they can't act on their own will because they have no minds, and they can't follow laws because they have no minds. So at this point, Descartes brings God into the picture as sort of the mind that's doing all the moving. So God moves all the bodies around. It's a sort of occasionalism. There's no direct influence between one bit of matter and another bit of matter. God's hands are on everything, moving everything around. It's like he's playing with action figures. He just moves them around. And he moves them around in accordance with laws that he gives himself. He can give laws, he can follow laws. Bodies can't give or follow laws. It's God doing all this stuff. Stuff can be moved around by God, but that's it. So that's Descartes' sort of picture. And moreover, for Descartes, the laws flow from God's nature. He has a theological analysis of God, and he says that from God's immutability, and he gives a bunch of argumentation, which we're going to skip over. It's important that it comes from God's very nature. Certain rules or laws of nature, which are secondary and particular causes to the various motions we see in particular bodies. So God's the primary thing, and from his nature follow these laws, which are the secondary causes. Now, I don't know if you all have seen a distinction between primary and secondary causes, but we'll get to that in a moment. So God's the primary cause, which is sort of occasionalism. God's doing all the work in the world, actually. Then what causal work then is there left for the laws to do? These laws are being invoked as secondary causes. What's that mean? And let me go through some of Descartes' thinking here. So going back again to this book by Ott, he notes that there's a very useful analogy here in the distinction between a determinable and a determinate. And this was a part of scholastic philosophy. A determinable would be something like color, and its determinate would be something like scarlet, a shade of red. So a scarlet object doesn't have two properties. It doesn't have being colored and being red. It just has being scarlet. And being scarlet is the determinate way it has of being of being colored. Scarlet is a color. It has a way of being colored. It's colored and scarlet, but there's only one property. Nothing's doing double work here. And so Descartes has a similar sort of explanation of what's going on with God's laws. The laws particularize and determine the actions of God. God has this volition to recreate the world at every moment, to sort of keep it going, one step forward, one step forward. And that's made precise and determinate in the laws. And this is related to another bit of scholastic philosophy, which actually Descartes maintains. And according to Aquinas, the way God acts in the world is sort of undifferentiated. It just has an intention to act towards the world, but he doesn't do so directly. There's a secondary cause, such as fire, and they would say with its power to burn, but Descartes would disagree. Must be on the scene to particularize and determine God's actions. So when God does things in the world, he doesn't just like turn your house into ash. He sets your house on fire, and the fire turns it into ash. Right? So God acts in the world via worldly mechanisms. And those are make determinate and definite his actions. And what Descartes wants to say, it's not the fire that has the power. It's not the fire that has the power to do that. It's the law that makes the particles behave such that. So he sees that similar idea of a secondary cause. Okay, so that's been Descartes on the laws. We get this sort of top-down, governing, theologically heavy picture. Because he thinks that there's no causal powers in the world, for sort of valid critiques of Aristotelian explanation. And then he's got his little soul's argument, which says that they don't have any minds to obey laws either, so it has to be God that does everything. It's roughly how his position works. Newton is our next player on the scene. He agrees with Descartes' critique of Aristotle and the scholastics. This is a quote from the second edition of the Principia, which had a preface, which was written by this guy Coates, but obviously Newton approved it. So we can take this as Newton's view. There have been those who have endowed the individual species of things with specific occult qualities on which they have then alleged the operations of individual bodies depends in some unknown way. The whole scholastic doctrine derived from Aristotle and the Peripatetics is based on this. Although they affirm that individual effects arise from the specific natures of bodies, they do not tell us the causes of those natures and therefore tell us nothing. So a very similar critique of the sort of Aristotelian metaphysics. But nonetheless, according to Newton, or at least some readings of Newton, there's some disagreement about this. There are, in fact, causal powers out there in the world. When he sets out his laws of motion, he's got his laws of inertia, and then he talks about forces and how forces cause things to behave non-inertially. And he gets very specific about that. So the forces, bodies have forces which they can impart on others by contact or by gravity, by different mechanisms. Those are to be found later and given their own laws. But we have a way of talking about these things. So for Newton to introduce a new force law like gravity is just to introduce a causal power and to say what it does. So every causal power comes along with a law that says how that causal power fits into the framework of other laws. This is sort of like that web of laws idea I was talking about earlier. So his law of gravity describes a power that all bodies have to change each other's motions. And now this mess of Aristotelian powers that we had is just a collection of competing forces. Bodies, all they can really do is enact forces on each other and change each other's motion. And that's the one power they have. But it is a real power to do things in the world. Maybe God gave them those powers, but it's the powers doing the work. So instead of that mess of Aristotelian powers, Newton's second law is sort of a law that describes how all the forces fit together. There's a law that says how all the forces combine, you add them up, and then you have the acceleration based on that total force. We have a way of combining all the different things, so there's no weird powers interfering with each other. There's just forces. The way they combine is just addition. and sort of has a explanation about this. So maybe that makes the powers less mysterious. Maybe it doesn't. There's plenty of room to critique on that. But how do these causal powers work? He's told us sort of how to make predictions of them, how they combine numerically in a theory to explain what's going on, but metaphysically what's going on, how does one body push on another, especially for gravity. Like he has this law of gravity at a distance. Instantaneously, if I have two massive bodies, if I wiggle this one starts responding immediately based on the change of gravity. Right? That's what Newton's theory directly predicts. So how do these causal powers work? How could that be the case? Newton doesn't think it's his job really to say so. And this is at a point when physics and philosophy are coming apart historically. And so Newton is a big player in that distinction. And he's quick to distinguish between two senses of the term gravity. Gravity, in one hand, is a sort of well-understood and well-modeled phenomena. I can identify it in the world, I can quantify it, I can make predictions about it. All of that sort of what he calls mathematical gravity is well unknown and well understood. There's no real pattern there. There's no real problem there. And that's what does the work in unifying the motion of apples and the motion of planets. Those are identified here in Newton's mathematical understanding of gravity. But if you want to know about gravity, the puzzling and unknown mechanism of instantaneous action at a distance, Newton has nothing really to say about that. And it's not that he just doesn't tell us, he tells us he's not going to tell us. And according to Newton, physics ought to progress by focusing on the former. Let's focus on the sort of mathematical, quantifiable aspects of the physical world, get to understand those and make predictions with those, and then the metaphysics, maybe it'll come later down the line. So we get this distinction between two types of explanation here. The scientific explanation, which unifies a wide variety of different kinds of phenomena, motions of apples and planets, within a single theory. And you can do all of that without explaining metaphysically what's going on. So we don't have a causal or mechanical account of why the phenomena happens, according to Newton. We just sort of deal with it mathematically and don't worry about the metaphysics of it. So he moves us back to a sort of Aristotelian powers view and shows how all the bits connect to each other, but then the real metaphysical meat of the question, how do they work, doesn't want to talk about that. So another distinction between Descartes and Newton on laws, it was important to Descartes' project that the laws proceeded directly from God's nature. And in principle, he could have figured them out from the armchair, just by reflecting about God's nature. He had this whole metaphysical skepticism, which he gets himself out of by invoking things about God. And so he thinks we can do that same method and figure out a priori with no experiments, because we might be being deceived by demons. We could figure out the laws of nature that way. And God wouldn't lie to us or mislead us, so we can trust our thinking. On these points, Newton and many others really strongly disagree. They think we should find out the laws of nature by doing experiments. And there's a tendency in this time period to call laws of nature, not to refer to the way that causal powers interact with each other, not to refer to sort of top-down governing view, but just report that there's robust experimental results. We go out, do experimental philosophy or experimental physics, and we find the law of reflection. When I shine a light on a mirror, it comes out at the same angle. And that's called the law of reflection. It's not some deep principle about the world, but it's sort of a very fundamental, not fundamental, but a very robust experimental result that you can go and repeat. And we found a law about how reflections work, and the refraction and Newton's law of cooling. So these are used, the term law of nature is used much more in an experimental context for just describing a regularity that we've found out in the world robustly and can recreate as we like. And this brings us to Hume, who has this sort of regularity view and dismisses all causal powers. He's like Descartes in being suspicious of there being causal powers in material bodies. His criticisms, however, are sort of an epistemic variety rather than a metaphysical complaint. According to Hume, he's a very much an empiricist, and he wants to say that all of our ideas come from experience. We're born not knowing anything, we experience stuff, and we sort of learn as we go along. But we never see causation in the world. All we ever see is constant conjunction. If we have two billiard balls bounce off of each other, let's say, we want to say that one caused the change of motion of the other. But we didn't see that. We saw them moving this way, and then we saw them moving this way. We didn't see the magic happen, you know? When you see somebody strike a match and a fire comes out, you didn't see the fire being caused by the match. You just saw striking and then flame. Just see these things conjoined all the time. That's what your experience is of, and then you start to sort of project causation onto that. Here's a quote from Hume. Our idea, therefore, of necessity and causation arises entirely from the uniformity observable in the operations of nature, where similar objects are constantly conjoined together, and the mind is determined by custom to infer from the appearance from the one from the appearance of the other. These circumstances form the whole of that necessity which we ascribe to matter, beyond the constant conjunction of similar objects and the consequent inference from one to the other. We have no notion of any necessity or connection. So all there is constant conjunction and our sort of impetus to connect them. That's all that there is to causation, at least if we're limiting ourselves to ideas which come from experience, which Hume thinks that's all we can do. So according to Hume, we have this causation, at least insofar as we can know about it, is merely a custom or habit that we have for linking causes with effects. We never really see that magic happen, and so anything past that sort of speculation, which he's skeptical of. And similarly for laws, we never see the laws, we never see the causal powers, we never see the laws. While we see irregularities out there in the world, that's what we sort of have experimental, empirical access to. And so we can do good metaphysics without making unfounded speculations about causal powers and about divine volitions. You don't need to suppose any of that speculative metaphysics. You can get by, and we ought to be able to get by for all epistemic purposes by treating the laws of nature as just efficient summaries of the world's patterns. Right? If all we care about is our ideas of laws, we want to ground our metaphysics in things we can, in principle, know about, then this should be our working definition of laws of nature. Right? Some people read Hume's critique here as being just epistemic in nature, so he's not saying there aren't laws in the world. He's not saying there's not causation out in the world. He's telling us if there is, we can't know about it, and we ought to do metaphysics based on what we can know about. And so as a sort of working principle, despite our skepticism about what the metaphysical world is really like, we should proceed as if it's just a summary of regularities. So some people take that sort of reading of Hume, which is just epistemic, and then we want to avoid doing speculative metaphysics, but we still want to do metaphysics. And so we go for this safe version of metaphysics out of skepticism, basically. Okay, so that's roughly a history of the concept of laws of nature that gets all the major views on the table. We've looked at the history of this laws of nature concept. We saw some historical examples of each one, and we will next analyze and critique various contemporary positions about these laws. Just to go over the history again quickly, we started with Aristotle with a bunch of causal powers. People got suspicious of the causal powers in the sort of Aristotelian framework. We moved to Descartes, but if we take away all the causal powers, we sort of end up with no capacity to obey the laws even, right? And then so Newton brought us back to causal powers in a way, with his sort of forces which combine to the actions, and he sees those as things in the world. But he doesn't want to do metaphysics, and he doesn't want to tell us what those causal powers are really or how they work. He sort of doesn't give us an answer there. And if we want to avoid any sort of speculative metaphysics in general, we shouldn't talk about causal powers or divine volitions. We should just think of laws just as regularities, at least in the way we work, because we're skeptical about maybe really going on out there. Okay. So that's all I had prepared for you today. Here are some references. If you want the slides, I can send them to you afterwards. I'd be happy to take any sort of questions about the course or about the history or about the laws of nature. Yes?
This might be quite basic, but between Aristotle and Ptolemy and all of them, and Descartes and Newton, there's 1,000 years.
Yeah.
What's going on broadly?
Yeah. Yeah, so I kept referring to these people called the scholastics.
Oh, yeah.
They were the medieval followers of Aristotle. So there was a sort of Dark Ages when less philosophy happened and it moved to the Islamic world and other places. And then translations of Aristotle came back into Europe, and people hooked onto those quite a lot. So these scholastics and not the Peripatetics, these were ancient, but the scholastics were medieval thinkers who sort of developed and kept working on Aristotle's ideas. But they were all sort of within the Aristotelian framework and didn't question it and didn't move out of it in a way until we get to like Descartes and these criticisms. So that was the standing philosophy in Europe for a long, long time. Yeah.
Thank you.
Yeah.
Professor, you mentioned Newton didn't want to talk about metaphysics.
Yeah.
And I'm just curious to know why he proposed the idea of absolute space at the beginning of his Principia.
Yeah.
It seems like an ontological proposition.
Yeah. Yeah. So he did make these strong claims about metaphysics of space and time, which is actually my primary research area. But the reason he did this is he thought it was necessary to make sense of his laws. So he felt he was sort of forced into it. I think by inclination he wouldn't want to do metaphysics, but he was forced into it because his laws talk about positions of bodies changing over time. There has to be time. There have to be positions which you can take like the derivative of to get accelerations, which feature directly in his equations. So he thought just for explaining, it was the sort of the space-time geometric background structure he needed to state his laws. So they were sort of already necessary for his picture. But other people disagreed. They thought we could do it with just relative positions. But there's the whole sort of Leibniz-Clark debate about these things. But Newton felt he was forced into saying that there were these absolute space and time.
So I'm curious, how do we draw the line between laws of nature and laws in the sense of like social science or science? So I was thinking of, you've been talking a lot about laws in physics.
Yeah.
And we could sort of move into laws that psychology posits, which still seems kind of like nature, but just maybe human nature.
Yeah.
And then you move to like social science and you say, for example, that if the Federal Reserve buys a bunch of bonds, then the interest rate will go down. Mm-hmm. That seems like a law as well, but maybe not a natural law. So like in these discussions, where are you drawing the line between the law of nature and other laws that do seem kind of robust, but don't seem to be like a legal sort of thing?
Yeah. Yeah. So I mentioned that thin concept of laws at the start, which was then playing an axiom-like role in a certain science. So that's a sort of discipline agnostic sort of working definition we can have. And as I mentioned, like Newton's law is an axiom in his theory, but not in Einstein's theory. So there is a concept of a derived law. When we do like theoretical reductions, when we want to reduce, we have our theory of chemistry and our theory of physics. We have their laws here and these laws here, and we want to say with certain definitions and extensions, we can like logically derive via some bridge principles these laws from those laws. Right. But they're all just still called laws. Like I mentioned with Newton, there's a tendency developing around this time period to use laws of nature just for any sort of robust experimental result in any discipline. We get laws of supply and demand, we get laws of this and that. And the law term is applied to lots of things in that way. And you can think of them as standalone laws.
So these would also count for like social science. This isn't just about natural science. This discussion here.
Well, yeah. So my discussion was on sort of the history, and this idea came about in physics. So later on, you apply it to other disciplines. Like this law of nature concept really catches fire. Everybody loves to talk about laws of nature, and it spreads widely without sort of the conceptual underpinnings staying fixed. So people just sort of have taken the term to mean lots of different things. And yeah, there's very interesting questions about how the laws of sort of the special sciences or the biology and higher relate to the laws of physics. There are some people who think that you can't do that sort of reduction I was talking about, like from chemistry down to physics. Some people think there's sort of a strong emergence, and the laws of this discipline, while they may be based on, or like the physical mechanism for it might be physical or whatever, but the laws here are novel in a significant way. The laws of biology, of evolution, of these things, like new principles in organizations come in at that stage, which can't be reduced to the lower ones. So we don't have to think that everything can be reduced down to physics. There's a possibility for novel emergence at different levels of science. But other people think it's all reducible to physics, like law by law, this whatever you call a law in your theory, whatever axiomatic foundational results you have, there's a way to connect it by some means down to the axioms of the physical discourse. So it's the axioms for discourses and how they might relate to each other. Yeah.
Presented in one of the slides the contrast between Descartes and Newton. Descartes taking the more, let's say, analytic, a priori view of laws, and Newton taking laws as robust experimental results. Now the question is whether you're in the next meetings you're going to talk about the analytic a posteriori option of viewing the laws, because this contrast is not exhaustive as we know today.
Yeah. Yeah, we can get to the. I haven't written the lectures for the later talks yet, so if you guys want to see anything in particular, let me know. We can include a discussion of this if you'd be interested. Yeah.
Because that's the way I view the laws. But
like to hear about on that?
Sorry?
What sort of thinker or argument do you have in mind? Or just the fact that it's not exhaustive and I should get all the views on the table?
We can talk about it.
Okay. Great. Yeah, but I'm still writing the lectures for the other parts, so let me know if you want to hear about anything particular. People surprised by any of this? I mean, did you find yourself shifting your intuitions from one view to the other as we went on? Or do people feel like they've got a pretty firm grasp of what they think? Who has a firm view on these sort of topics? Anyone?
Define firm.
Just have strong intuitions or strong arguments. Strong intuitions or strong arguments, either one.
Yeah.
Okay, what's your intuition or argument?
I think that laws are analytic a posteriori.
Okay, we'll come to this then. The Descartes' governing view was very theologically heavy, let's say. Some people like the intuition of the governing view, but don't want all that theology in it. And so what I was thinking of talking about next is some sort of contemporary views of governing laws that aren't so theologically heavy, and that try and get at that concept without so much God talk. Yeah? So I think that's what we'll talk about next. Then in lecture 3, there's been in metaphysics a sort of return to Aristotle. People starting to, despite all those severe criticisms of sort of causal powers, people sort of want to go back to them in a way. And so I'll talk about some contemporary attempts to return to the causal powers view. And then there's a lot to say about Hume. This is probably the most popular view in the modern discourse, is the sort of Humeanism. And I have a lot to say about that with like David Lewis and the best systems analysis and things. And lots of variants of this people can consider. So that's what I'd like to talk about. You all are free to go.
Thank you.